Hi, I'm Kian. In this video, I'm going to show you how to solve this stoichiometry problem, which is typically, this is more involved with the epichemistry content. So you have this question. So 250 milliliters of a 0.15 molarity solution of ammonium sulfide, which is basically NH4, 2, and then S, which is the sulfur, is poured into 120 milliliters of a 0.053 molarity solution of cadmium sulfate. So it's a CD cadmium SO4, and we want to find how many grams of cadmium sulfide or CDS is formed, and we also given that the other product of when NH42S and CDSO4 are chemically combined is NH42SO4, which is basically, so we're also given the other product. So what you have to do is, first of all, you have to write the chemical equation. So how do we do that? So it's pretty simple. We have the reactants, and I'm going to change how I write this to make this easier. So I'm going to write it as this. So the reactants here would be, so you have N2, then you have H8, and then we have S, and I'm going to add that. So we have plus, we add it to cadmium sulfate, which is CdSO4, and we are given cadmium sulfite, PS, plus, and I'm going to write this as N2H8, and I hope you don't mind, I'm going to write this as SO4. Now, you have to make sure that this is balanced. And how do we make sure? So we have N2 in the left. We have an N2 on the left. That's good. We have an H8. We have H8, so that's good. We have an S and S. So we have two sulfur. And then here we have two sulfurs as well. So we're good. You have one cadmium. That's good. And then you have O4. So this equation, in fact, is balanced. So we can basically skip this part and go to the next part. So what do we do first? So to solve this problem, this is a very basic stoichiometry problem. This would have been a basic stoichiometry problem if we were given the moles of each reactant. If we were given, for example, the moles of N2H8S or cadmium sulfate, if we were given these, we could just find which one of them is the limiting reagent, and therefore basically do simple calculations to find how many grams is formed. But we're not given that. But we're given two essential numbers. That is the volume of basically that solution, and also the molarity. And we know that the molarity is basically of a solution is the number of moles of that solution over the volume. But the volume has to be in liters. So therefore, what we do is basically, I'm going to kind of skip that process of calculation, but we can basically show that the number of moles, so moles of N2, so actually, so this, the moles of this would be basically, so we're given the volume, 250 milliliters, and we're given the molarity. But the molarity is number of moles over the volume. So we basically multiply that, so 0.15 times 250, but we have to divide it by 1,000 because we want it in liters and not milliliters. So the molarity, the number of moles of this solution is 0.0375. 75 moles. Now we can do the same thing with cadmium sulfate. We're given the volume, 120 milliliters, and we're given the molarity as 0.053. So if you multiply that and then divide by 1,000, since we want it in liters, we see that we get 0.00636. Now, this is basically a two-step problem. So we have to find the number of moles of each reactant, but also to choose which which solution you want to choose from, and that is basically the limiting reagent problem. So which of these solutions are the limiting reagent, and that is the one that has um, uh, the the smaller amount of moles. And so we knew that when, for example, we're given, for example, grams of two different solutions in which they're both reactants, we first of all turn it into moles, and then if there are any coefficients, we divide it by that. But here, since the coefficients are just one, and we're given the moles, we see that, in fact, cadmium sulfate is the limiting reagent because the number of moles of it is much smaller than that of N2H8S. And therefore, we can actually go on with the usual way of solving stoichiometry problems, in which we start with this amount of moles of cadmium sulfate. So we set up our proportion. So we have 0.00036 moles of CdSO4, and we can multiply that because there's 1 mole. We can look at the ratios and also the product. There's 1 mole of cadmium sulfide per 1 mole of cadmium sulfate. And then since we want the amount of grams, we just have to multiply by the molar mass of cadmium sulfide. And in fact, if we take the molar mass, so the molar mass of sulfur is approximately 32.07. And if you add that to that of cadmium, so if we find cadmium, we see that it's 112.41. So 32.07 plus 112.41, we get 144.48. So times 144.48 grams of cadmium sulfate per 1 mole of cadmium sulfate. And we can see that basically all of these cancel out because the moles of this cancel out with the mole of this and the mole of this of this. And so what we're left off basically is the gram of cadmium sulfide. And that is, so 144.48. And then we multiply that by 0.00636. And if we kind of round it to maybe 2 sig figs, we get 0.92 grams of cadmium sulfide. And that's the problem. Thanks for watching. I hope you enjoyed it, and goodbye.